Hello students, how are you? Let's start. Ray of light. A ray of light is a hypothetical phenomenon which is used to describe the rectilinear propagation of light theoretically. That is, last day we said light travels in a straight line. Okay, so this straight line represent a ray. So if I consider two straight line, that means there are two rays. If I consider three straight line, then 1 2 3, there are three rays. Understood? So, and next the collection of these rays are called beam of light. What? A beam of light, the collection of rays. Converging ray and another is diverging ray. What is converging ray? Now the type of rays that meets at a point is called converging rays. Suppose there are three rays, it travels in this direction, it travels in this direction, and it travels in this direction. So these three will meet at a point. So if some rays meet at a point, then those rays are called converging rays. But if the rays emerges from a point, then these rays are called diverging rays. Understood? If rays meet at a point, then these rays are called converging rays, and if from a point rays emerges, then those rays are called diverging rays. Okay. There are also a third type of rays called parallel beam of rays. If the rays remains parallel with each other, then that type of rays are called parallel beam of rays. So there are total three different types of rays. One is converging ray, second is diverging ray, and third is parallel beam of rays. Okay. So reflection of light, this is the process of bouncing back of light from a surface. If we consider it as a surface, what we will observe, if a ray falls on it, it will be reflected in some other directions. Okay, so this process actually called a reflection of light. If a ray falls on a surface, it will be reflected back by the surface. Next, this reflection of light always involves two different rays. One is incoming ray or incident ray, and another is outgoing ray or reflected ray. In this figure, if we consider it A, O, B, then you can tell me that AO is the incoming ray, so we can say that AO is the incident ray, and OB is the outgoing ray, that is OB is the reflected ray. And if we draw a perpendicular at this point, this is perpendicular on the reflecting surface, giving it a name ON. This is called the normal. It is a imaginary line, it has no actual existence. AO is the incident ray, OB is the reflected ray, and ON is the normal. And this specific point O, it is called point of incidence. Okay, this point O is called point of incidence. And there are two other terms which are used to describe the reflection of light. One is angle of incidence and another is angle of reflection. First, the incident ray and the normal. midday angle. This is the angle of incidence, and the angle made by the reflected ray and the normal is called angle of reflection. Clear? The angle made by the incident ray and the normal is called angle of incidence, and the angle made by the normal and reflected ray is called angle of reflection. Clear? So these are the terms that are used to describe the reflection of light. One is incident ray, another is reflected ray, normal, angle of incidence, angle of reflection, point of incidence, and CD. This is called the reflector. Next, the types of reflection. Based on the nature of the surface. Nature of the reflecting surface. If the surface is smooth and if the surface is rough, the reflection made by the smooth surface is defined as regular reflection, and the reflection that occurs on a rough surface is called irregular reflection. Okay, so next, regular reflection of light. This is a smooth surface, and these are the incident rays parallel to each other. They are called parallel beam of rays. In this case, what we will observe that after reflection, it travels in this direction. It will travel in this direction, and it will travel in this direction. If you look it closely, then you can say that the reflected rays are also parallel to each other. Incident rays were parallel to each other, and the reflected rays will also become parallel to each other. So this type of reflection, when the reflected rays also remains parallel with each other, then this type of reflection is called regular reflection of light. And in a definition you can write the phenomena due to which the parallel beam of rays in a specific medium on striking a smooth polished surface bounces off from it as a parallel beam of rays in some other fixed directions. It's not that it will travel in this direction, it will travel in this direction. In other some fixed directions is called regular reflection of light, and the images formed due to this regular reflection of light in mirror. Irregular reflection of light. So as I already said that regular reflection of light happens on a smooth surface, and in other case the irregular reflection takes place in a rough surface. So consider it as a rough surface. These are the parallel beam of rays incidents on this rough surface. So still they are parallel with each other, but what we will observe that after reflection it travels in this direction, it travels in this direction, and it travels in this direction. So are they remains parallel with each other? I don't think so. This type of reflection, when we observe that the reflected rays fell to remain parallel with each other, then this type of reflection is called irregular reflection of light. Okay, so there are so many importance of this irregular reflection of light. First of all, we can see our nearby things due to this irregular reflection. And second thing, in day, by the irregular reflection of light by molecules in our atmosphere, we can see everything in our room, though the sunlight never comes directly into our room. Okay, so there are many differences between a regular reflection and irregular reflection. This is your homework to prepare the difference between a regular and irregular reflection. Next, laws of reflection. There are two definite laws of reflection. First law of reflection states that in case of reflection may be regular or irregular, the angle of incidence is always equals to the angle of reflection. So if I consider it is surface, this is the incident ray, this is the reflected ray, it is the angle of incidence and it is the angle of reflection. So according to the first law of reflection, the angle of incidence is always equal to the angle of reflection, that is I equals to R. If I becomes 30 degree, R also will become 30 degree. This is the first law of light of reflection. So for normal incidence, if anyone asks you what is the value of R, for normal incidence what is the value of R, then the answer is, suppose this is a surface, normal incidence means lights falling perpendicular on the surface. So here this is also the normal at the point of incidence. So I equals to 0, and according to the first law of reflection, if I becomes 0, R will also become 0. And we will also observe that if light falls perpendicularly on a surface, it will be reflected back perpendicularly, that is light will come in this way and will move in this direction. Okay, so if the for normal incidence, angle of incidence will become 0, for this reason R will also become 0 degree. Next, the second law, reflection. This second law of reflection states that the incident ray, the reflected ray and the normal drawn at the point of incidence all lie on a same plane, that is the plane of all the three rays, incident ray, reflected ray and the normal are same. And as an example, if I consider it as a reflecting surface and this is the incident ray and this is the reflected ray and this is the normal, then incident ray, reflected ray and the normal will lie on a same plane. So it will look like this. Okay, you can see this. It's not possible that the ray comes from this direction and reflected in this direction. It's not possible. If it falls on the surface in this direction, it must have to reflected in this direction. That's called the second law of reflection. Now object and image. First, object. What is the definition of object? Anything which acts as a source of light is called object. Maybe it is luminous or non-luminous, like chair, table, sun, you, me, all are the objects. And what do you mean by image? It is an optical appearance or optical counterpart produced by light of an object by reflection or refraction. That is, if a person stand in front of a mirror, he can look another person like him. So this is called the image of this object. It is object, it is image. So it is the optical counterpart. It is the everything is same of the image like object. There are no difference. Maybe there are some differences in size or inversion, lateral inversion, that we will learn later, but there are no other differences. Like if he is Ram, it will not become Rohim. There are no such cases. Okay, so image actually the counterpart of the object, optical counterpart, and there are two different ways by which the images are formed. In first cases, the rays that coming from the object meet at a point, and in second case, rays appear to meet at a point. So when the rays meet at a point to form an image, then that type of image is called real image, and when rays appear to meet at a point, then virtual images are formed. So we will study more about real image and virtual image. Just this is a rough idea. When the rays of light meet at a point, real images are formed, and when the rays of light appear to meet at a point, then virtual images are formed. Okay, so next, now we are going to draw some ray diagrams of formation of image. Okay, and the process will be discussed later. Right now just follow the last 2 points: meet or appear to meet. This is the two incoming rays, and after reflection it moves in direction and it moves in direction. So the two rays meet at a point. So if here the object, then the image will form at that point. So remember the last point: if the rays meet at a point, then what type of image will be formed? Real image. So this image is real image, and this is the two rays, and after reflection it travels in this direction and it travels in this direction. So tell me, is it possible that these two rays will meet at any point? It moves in this direction, it moves in this direction, so they will never intersect with each other, that is, they will never going to meet. So we can consider that the rays are coming from this point. Okay, so actually there are no rays, but we can consider these rays are coming from this particular point. So actually, as this particular point is not formed by the rays of light, so we can say these rays appear to meet at this point. Okay, so this is a image. Here is the object. In this case, the rays meet at this point, and in this case, the rays appear to at this point. So this is real image and this is virtual image. Clear? Now you can prepare the definition of real image and virtual image. Okay, so in our next class we will study about different type of reflecting surfaces, that is plane reflecting surface, curved reflecting surfaces. Okay, thank you.